Good morning, everyone. We will present the data encryption standard.
Data Encryption Standard Algorithm. The Data Encryption Standard or DES is a symmetric key algorithm encryption that was widely used in the past to protect sensitive data. It was developed by IBM in the 1970s and later adopted as a standard by the US government for encrypting sensitive but unclassified information. The algorithm works by taking a block of plaintext and secret key as input and then performing a series of substitutes and permutations to produce a block of ciphertext. DES brute force attacks, which involve trying all possible keys until the correct one is found, although DES is no longer considered served by modern standards. It remains an important part of the history of cryptography and paves the way for more advanced encryption algorithms.
This is the table of content, the history of this, description, and the example of this algorithm. The history of data encryption standard algorithm. The data encryption standard algorithm, or DES, was developed in the early 1970s by IBM in cooperation with the National Bureau of Standard, now the National Institute of Standard and Technology, or NIST. It was the first widely used encryption algorithm and was adopted as a federal standard in the United States in 1977.
DES was designed to provide secure encryption for electronic communications and data storage by using a symmetric key encryption scheme. The algorithm uses 64-bit encryption key and operates on 64-bit blocks of data. It employs a series of substitution and permutation operation included the Fistel structure to provide strong encryption.
DES can be implemented through software or hardware, and it requires a secret key to encrypt and decrypt data. Software implementations are typically written in high-level programming languages and compiled into machine code, while hardware implementations can be more efficient and are often used in embedded systems. The use of encryption algorithms like DES is crucial for maintaining the confidentiality and integrity of sensitive information in various contexts.
Step in computing DES. Number 1. Key generation. The 64-bit encryption key is provided as input. This key undergoes a permutation and compression process to produce two 48-bit subs key, which are used in the encryption and decryption process. Sample. Let's say the 64-bit encryption key is represented as a binary string. The key undergoes a permutation process which rearranges the bits according to predefined table called a permutation table. This table determines the order in which the bits are rearranged. The result is a new binary string with 56 bits, which is called the name permuted key. Next, the permuted key is divided into two halves of 28 bits, each called C and D. These halves undergo a compression process which reduces each half from 28 bits to 24 bits. Number 2. Initial permutation. The 64-bit plain text message is permuted according to a fixed table. Example of initial permutation in DS. The initial permutation involves permuting the bits of this message according to a fixed table called the initial permutation IP table. The IP table specifies the new position of each bit in the permuted message. To perform the initial permutation, we simply take each bit of the plain text message and place it in the position specified by the IP table. For example, the first bit of the permuted message is the 58 bit of the plain text message. The second bit is the 50 bit and so on. After applying the initial permutation, the permuted plain text message looks like this. As you can see, the bits of the plain text message have been rearranged according to the IP table. This permuted message will be further processed using a series of substitution and permutation operation to generate the final ciphertext.
Number 3. 16 rounds of encryption. Each round involves the following steps. A. Expansion. The 32-bit plaintext block is expanded to 48-bit. XOR. The expanded plaintext block is XORed with the 48-bit sub-K for the current round. C. Substitution. The resulting 48-bit block is split into 8 to 6-bit blocks, each of which is substituted using different S-box. D. Permutation. The resulting 32-bit blocks is permuted according to the fixed table. Number 4 steps. Final permutation. The resulting 64-bit block is permuted according to the fixed table. The decryption process is the reverse of the encryption process, with the sub-K used in reverse order. Note that this is a complex algorithm and there are many technical details involved in each step.
Ang code na ito ay nagpapakita ng isang halimbawa ng paggamit ng DAS algorithm sa pag-encrypt at pag-decrypt ng isang plain text message. Gamit ang isang secret key, narito ang mga details ng code. First, ang import. Ang import statement ay nagpapakita ng mga klase na gagamitin sa code tulad ng cipher at secret key spec. Ang key variable ay naglalaman ng secret key na gagamitin sa DES algorithm. Ngayon, sa main method, ang plain text variable ay naglalaman ng plain text message na kailangan i-encrypt. Gumagamit ng cipher object ang code para sa DS encryption, and ang cipher get instance naman ay tumutukoy sa DS algorithm. At ang PKCS5 padding ay nagpapakita na kung paano mapapad ng message upang mag-fit sa 64-bit block size ng DAS. Ang secret key spec ay gumagawa ng isang secret key object mula sa key bytes. And ang cipher init method ay nagpapakita ng mode ng operation ng cipher. Sa kaso ng code na ito ay encrypt mode. Ayan. Gumagamit ng doFinal method ang cipher upang i-encrypt ang plain text message. At ang resulta ay nakalagay sa ciphertext variable. Gamit ang base64 class, ginagawa ng code ang base64 encoding ng ciphertext upang mapadali ang pag-print at pag-transmit nito. Sa pag-decrypt ng ciphertext, Ginagamit uli ng code ang cipher. Object na ito ay ini-initialize na sa decrypt mode. At ang do final method ay ginagamit upang i-decrypt ang ciphertext. Ang decrypted plaintext bytes variable ay naglalaman ng decrypted plaintext message. At ang string object ay ginagamit upang i-convert ang byte array sa UTF-8 encoding ng plaintext. Sa huli, nagpapakita ang code ng original plaintext message at ang decrypted plaintext message. And etong code na ito ay simple example ng paggamit ng DS algorithm sa Java programming language.
In summary, this is a symmetric key encryption algorithm developed by IBM in the 1970s and then adopted by the US government. It takes plaintext and a secret key and performs substitutions and permutations to produce ciphertext. It is designed to be resistant to various attacks, including brute force attacks, although no longer considered secure. It paved the way for more advanced encryption algorithms. This can be implemented through software or hardware and is crucial for maintaining the confidentiality of sensitive information. The algorithm involves key generation, initial permutation, 16 rounds of encryption, and final permutation.